Okay, now wait a second. So, for those of you who are jinxing us by going and looking at Snow Day Calculator and seeing 99%, think back to what happened on Wednesday. So, if you look at the weather report, it's that the snow starts when? About like 10 o'clock or so in the morning tomorrow. It's gonna like do a light dusting from like 1 a.m. and then the dumping snow comes at like later on in the morning. So the best thing that we can hope for is that it either comes like 6 hours ahead of schedule or waits on us. But anyways, welcome back. Happy Leap Year Day. Any leap year babies here? Any of you? Just Magnus. All right. Okay, the other thing is, do I have anybody in here who didn't take the LTA? Ryan, why do you always have to make like a mess? Okay, so just note to self, the second person always gets caught. It's how it works out. That's what I tell my kids. But anyways, back to me. Anyways, if any of you didn't take the LTA on Friday, today would be the day to do that. I've got them graded. You guys did pretty well on that. There were a few little itty bitty mistakes that I want to talk to you guys about to kind of go over what, just so that you don't make those same mistakes again when we do the unit exam. What I would like to do this week is wrap up two-dimensional motion. At some point, once we do that, we're going to have a unit exam. I don't know when that's going to be, if that's going to be Friday or if that's going to be early next week. It all depends on things. Having, as much as I loved the snow day last week, it really set us behind. So I've got a lot of catching up to do. What I want to do today is kind of go over a little bit with horizontal and vertical components of projectiles. We started that on Friday when we were together, and I just want to make sure that you guys understand how that works. Because last Friday when we were together, we talked about, we started that Mythbusters movie clip. We're finishing it today. We've got about 8-9 minutes left of that. But the idea there is that you've got this, you're comparing two things. You've got this bullet that you're dropping. At the same time, you're firing another bullet from the exact same height. And what they're trying to do in that is see, do those bullets land at the exact same time? And what that does is that kind of helps us with understanding the relationship between these horizontal and vertical components of objects that are in projectile motion. So you guys are going to be guinea pigs. I've got two different questions here, and we're going to use something called plickers.
Blue clickers.
Not clickers, plickers. Have you done those before?
The blue clickers?
No.
Have you done the blue clickers before?
No.
Yeah, those are sweet. In elementary school, we'd have these blue clickers. You'd have like a number, like a class number. So you'd have to point on the screen, like log in. It's like Kahoot kind of, but like these like blue clicker things.
So this is kind of sort of like that, except it's on paper, not with blue clicker things. All right, so here's how this works. I need everybody working with me here. Okay, so you notice how you've got this blob or whatever it is. Everybody has a different one, but here's what it does. If you look at it, do you see how it has like A, B, C, and D? Yeah. The way this works is if you want to answer A, you make sure that A is pointed up. If you want to answer B, you just turn it so that B is pointed up. If you want to do C, you point it so that C is pointed up. And if you want D, you point it so that D is pointed up. So here's the first question. Okay, you've got a cannon, and it's at the top of a cliff because if you're going to put a cannon anywhere, it might as well be there. And you fire it off, and the question is, which of the paths does the cannonball most closely follow? So you've got A that's right down here, B, C, and D, and there is no E. So here's what I need you to do. On your little plickers thing, I need you to decide, is it A, B, C, or D? And then in a second here, I'm going to have you hold that up. Yeah.
Just goes down at a perfect 45-degree angle from the barrel.
All right, so here's what I need you to do. Hold those up so that I can see them. Oh, yep. It's getting everybody's except Spencer's. Interesting. Okay. So here's what I got for this. 15 of you said it was B, and 4 of you say it's C. All right. Okay, so here's the next question. Next question is this. You have a bowling ball that just happens to accidentally fall outside of an airplane as it flies along in a horizontal direction. And somebody happens to be sitting on the ground watching this bowling ball fly out of the airplane. Okay, which of the paths, so these are the paths right here, which of the paths does the bowling ball most closely follow from somebody watching on the ground? So is it going to be A, B, C, D, or E? All right, so hold them up for me. What's that? No, E's not. Right. So what you got? We don't know yet. Okay, here we go.
Well, what if it has I was thinking if you just drop it out of the plane, it only looks like it's moving in the right direction.
That's a straight line.
You're messing it up, Alicia. It's all confused now.
Because the plane is still moving.
Stop.
Straight line, the plane's going to be moving. That's why they move out.
Am I good? I'll get it, Sarah.
They don't have any horizontal movement. They're just falling, but the plane is moving. Therefore, they're going to look like they're That's why when the missiles jump out of a helicopter, they
Can we change our answer?
that way unless they get pushed by wind. Just go straight down.
Interesting.
I think I put the wrong
Saying that word.
All right, so this is what we got. 5 of you chose A, 1 chose C, and 13 chose D. So what we're going to do today is talk a little bit about this and make sure that you guys understand what's going on when you have these objects that are moving in projectile motion. So we're going to come back to this in a little bit. So we'll talk more. in a little bit. So like I said, on Friday, you guys started that Mythbusters episode with the idea that you were comparing those different bullets. One that was being dropped, the other one that was being fired. And the question is, do they hit at the exact same time? So what I want to do is, as long as people are paying attention, we'll finish that up. Okay. If not, then we'll just move on to the next little piece of today. So.
At the same time. Yep. Gravity, man. It's not just a good idea. It's the law. Confirmed.
Okay, so there was that. That took a while, but I think it was worth it to talk about this because, okay, so remember, here's what they're doing, and what we're trying to do is we're trying to make sure that we can explain what's happening with the horizontal and vertical components of objects that are in that projectile motion. So let's say this is a bullet. Let's say this is a bullet, and I'm just dropping it. Okay, describe what's happening motion-wise. Okay, you said gravity. What do you mean by gravity?
It's going to get pulled down by gravity.
Okay, so it's going to get pulled down by the force or by gravity.
Yeah.
Okay, constant motion or constant velocity, acceleration. What's okay? So it's accelerating. It's speeding up as it goes down. So let's say that now I've got my bullet that I'm shooting. Okay. Ooh. All right. Describe what's happening there. Is gravity working on that?
Yeah.
Yeah. Okay. Is gravity the only thing that's working on that? No. What else is?
The force you applied on.
Okay. So the force that I applied to shoot it off that way. So in which direction is gravity working? It's working down. So it's in the vertical. Okay. When I shoot the bullet, okay, is gravity still working on it?
Yeah.
So it has a vertical component. Okay. And what makes it go horizontally?
Force applied on.
Yeah, that gunpowder or the force that we apply to it. So that has the shot bullet has both a horizontal and a vertical component to it. Now, so tell me, how is it possible then for a bullet that is dropped and a bullet that is fired from the same height, how is it possible for those to hit at the exact same time?
Falling down at the same speed.
Okay, so say that louder.
They're both falling down at the same speed.
Okay, so they're both falling down at the same speed. Ryan, did you have something? All right. So does gravity pull on one differently than the other? No. It's pulling it down at the exact same rate. So that's where it's going to be so important that you understand that when it comes to the horizontal and vertical components, they are separate. Okay? Whether you're dropping something or whether it's shooting out of a gun or somewhere in between, they're all falling at the same rate. The only difference between the two is that the dropped bullet only has that vertical component. The projectile has a horizontal and a vertical one. So this is what we're going to do. This is what we're going to do next. You guys have whiteboards at each of your tables. So you're going to need to kind of work together on this. But here's we all need. So are you guys going to okay, you can take it over there if you want, but okay. Who's catching?
Yeah, I'm on.
All right, that was my bad. All right, so we've got this. All right, here's what I need you guys to do. And this is going to be, you're going to do this on your whiteboard, and I need to be able to compare. We've got about about 20-ish, maybe a little bit more, 24 minutes. So we should be able to get through this. Here's what I need you to do. On your whiteboards, I need you to kind of separate them in half. So long ways. Is that hot dog? Is that what? Okay. So draw a line halfway down the middle, hot dog style. And then on the left-hand side, take that and also divide it in half. Label one of them vertical motion and the other one horizontal motion. So here's what we're going to do. We're going to take two different scenarios. One's going to be in the vertical, and one's going to be in the horizontal. So for the vertical one, so for this one up here, here's what we've got. We're going to say that we've got a ball that's being dropped off the edge of a tall platform. We're going to assume that baby G, that acceleration due to gravity is 10 meters per second per second. Here's what I want you guys to do. I want you to set up a data table where you are determining the ball's speed and distance traveled for each of the first 5 seconds. So after 1 second, what's its speed? How far has it traveled? After 2 seconds, what's its speed? How far has it traveled? 3 seconds, 4 seconds, 5 seconds. What's its speed? How far has it traveled at each of those second marks? And then I need you just to sketch. It doesn't have to be fancy, but just sketch a distance versus time graph and a velocity versus time graph for that falling ball after 5 seconds. Then down below here, here's a horizontal scenario. And in this case, you have a ball that's moving along a frictionless surface, and it has a horizontal velocity of 20 meters per second. Once again, determine the ball's speed and velocity, or speed and distance traveled for each of the first 5 seconds, and then create a distance versus time graph and velocity versus time graph for the first 5 seconds. But here's where third hour got messed up. So hopefully we can avoid that. What equations are you going to use in the vertical motion? How are you going to figure out the velocity and the distance traveled for each one of those? So what would be the velocity and the distance formula for those, for free fall? Take a look at your notes. Get those out. Okay, so distance is 1/2 acceleration due to gravity times time squared. There you go. How are you going to figure out velocity?
Isn't it just acceleration times time?
Yeah, so velocity is the acceleration due to gravity times time. Now here's the other place where third hour messed up. In the horizontal motion, is gravity causing that to accelerate? No. So think about how you might have to figure out things differently in that case. All right? So I'm going to let you guys work on this. And in about 10 minutes, we're going to do the second half. All right. So let's take a look at this. So you guys just got done doing the calculations for the vertical motion. So that's if you just drop the ball, you take it, you drop it, and what does it do? It falls. And how does it fall? Down. Falls down. Okay, so maybe I should be more specific. Is it going at a constant speed? Is it accelerating? Is it? It's accelerating. So as it goes. Okay, as it falls, it keeps getting faster and faster and faster. Compare that to the horizontal motion. Okay, compare that to the horizontal motion where it's traveling along that surface. How is that one moving? Okay, so there's no acceleration because it's frictionless. So it's going at a constant speed. So here's what I want you to do now. Okay, this is for the next part. Okay, in this scenario, we've got a ball that's rolling along at 20 meters per second on a very tall frictionless platform and falls off the edge. Okay, so we've got this thing right here. It's rolling along, going along at 20 meters per second. As soon as it hits the edge, what does it start to do? Fall. Okay? So think about our Mythbusters. Think about what was happening there. In this case, you have a horizontal component and a vertical component. By the way, this would work the exact same way if it was shot out of a cannon or if it was dropped out of a plane. Hint, hint, nudge, nudge, wink, wink. All right. Here's what I want you to do. Okay? You notice that right here on this part that you already did, this was the vertical component of an object that's dropping. Okay? Down here, this was the horizontal component of a object that's traveling along at 20 meters per second. What I need you guys to do now is to combine those. And here's how you're going to do this. In this part of your whiteboard, you're going to make this this XY axis. So right here, right at this spot, this is the part where the ball falls off the edge. So this is the horizontal. This is the vertical. What I want you to do is be really precise on this. So when you do this, I want you to set it up so that on your whiteboard you have this XY axis where 2 centimeters equal 10 meters. So you're going to need to set that up so that 2 centimeters equals 10 meters across and 2 centimeters equals 10 meters along the horizontal. And then I want you to plot where the ball would be after 1 second, 2 seconds, 3 seconds, 4 seconds, and 5 seconds. Okay? All right, guys. Go for it.